Yes, hello ladies and gentlemen. My name is Migo Jean de chemistry teacher at College de Ruhanga. Now we are going to see the unit 3 called formation of ionic and metallic bond. Yes, by starting with this question should be answered after learning this topic. Yes, then differentiate ionic, covalent, and metallic bond. By using example for ionic and covalent, use a dot and cross diagram. Differentiate ionic compound from covalent compounds. State all factors affecting metallic strength. Differentiate malleable from ductile. Lattice entropy and compare lattice entropy for sodium chloride and magnesium oxide. State two many factors affecting lattice entropy. Then why ionic compound is a brighter and hard. What is electron C motor? Yes, this is the question you have to answer after learning this topic. Then, formation of ionic and metallic bond start. Then, what is the ionic bond and covalent and metallic bond? By definition, is a bond between metal and non-metal, where there is a transfer of valence electron in ionic bond, but in covalent there is a share of electron, or valence electron, and it occurs between metal only, whereas metallic bond is formed between cloud of free electron and the positive charge ions in metal called electron C model. Example occur in metals like sodium, magnesium, and etc. You are going to see, yes. Also, this is also the definition. Yes, ionic bond is a bond between one atom donate. Yes, one atom donate. Yes, one atom donate valence electron to another atom, whereas covalent is a bond formed between atoms by share of valence electron. Yes. Whereas metallic is a bond between a cloud of free electron and positive charge ions. Yes. Then atom achieves stable electronic configuration. By transfer the ionic and or share this covalent of electron. As a result, the bond becomes stable with well-defined strength and energies. This is the difference. By using the pictures we have seen this is we have ionic. Yes, we have ionic. This is the difference between ionic and covalent bond. Here there is this is there is a transfer of electron. Then from this from A is a metal, B is a non-metal. There is the electron move from metal to non-metal. The result is this. This A is positive because whereas this B is a negative. Examples. First is we have first is we have hydrochloric acid. Example, hydrochloric acid. Yes, also or sodium chloride. Sodium chloride. This is the example of ionic bond. There is a then for covalent bond, there is a sharing of electron. There is a share of electron. Here there is a share. This is here we have the share. Yes, here we have the share of electron. There's a covalent. This is a non-metal. This is a non-metal example. We have a chloride. Let us call this chlorine. And also this is a chlorine. Finally, we'll have this like this. We'll have chlorine as this bond is a covalent bond because there is a share of electron, not a transfer. Ionic versus metallic bond. In ionic, we have seen the transfer of electron. Yes, here as we have seen. Then for metallic bond, there is electrostatic attraction between electron cloud and metal nuclei. Yes, nuclei. Here we have the positive and this is the negative. This is the negative. Yes. This called is electron C model. Let us see. Then you have the difference between ionic and covalent compounds. Yes. Yes, ionic compound, yes, has a high melting point due to electrostatic, yes, have high melting point due to, yes, electrostatic attraction force. And it has whereas this is a lower melting and boiling point due to weak van der Waals forces. Then there is a bad conductor of heat and electricity, and here ionic is good, whereas covalent is a bad due to no free electron. Yes. So what is electron model? Electron model in metallic bond. Yes, in metallic bond, all metal atoms put together their valence electron. Yes, in a kind of pool of electron where positive metallic cation seems to behave like electron model. Or in this diagram, the valence electron are 3, delocalized and mobile. Yes. Metallic bond is the attractive force between metal cation and C electron. Yes. According to the picture electron C model diagram, you see we have a positive, we have a negative. This is the electron C model. This positive from metal. Then there is the electron. The electron I move. This is example. This is the metal. Example sodium. This is example as sodium ions. Sodium ions. Yes. Also, this metal electron C model, according to the pictures, this positive ion from metal, yes. Example, we take an example as sodium. This positive, it is from metal, whereas electron cloud, this negative, yes, does not belong to any metals ion, but it is act as electron C models. Yes, therefore, we are going to see the factors that affect metallic strength. Yes, metallic strength depends on the charges. As charge size, as charge increase, the metallic strength also increase. Yes, there is one factors. Charge ions. More charges, stronger metallic attraction between positive and delocalized electron. Here, magnesium, aluminum has more metallic than magnesium than sodium. Why? As charge increase, also metallic strength increase. Then the second point, size of atom. Small atom, the stronger force. Yes, the third one, number of hydroxide the electron per atom. As the number of hydroxide the electron increase, also the metallic strength increase. The 5 factors of five physical properties of metals. We have malleable, means that is a metal that can be hammered into sheet. Where ductile is a metal can be drawn into wire and rods. Yes, shine or lustrous can be reflected to a photolite. Example, this aluminum and silver are shiniest, while gold is more shiniest, whereas mercury is a liquid metal. Also shine and special telescoping. Yes, also the fourth physical property is electrical conductivity. Metal is a good conductor, yes, due to, yes, fractal. Whereas also high boiling point, why? As melting point increase as due to greater number of valence electron. Means that as the valence electron increase, the melting point also increase. This is the five physical property of metal. What is isoelectronic? Yes, and what you show it between this sodium and the magnesium ions. When two atoms have the same configuration with noble gases, example sodium, magnesium, yes, and magnesium and oxygen. First is magnesium plus, and this you have this electronic configuration. For chloride, also you have this one. This because they have we have this 8 electron outermost chain, means that sodium is isoelectronic with chloride. For magnesium and oxygen, also it is according to the electronic configuration are the same. This is the same as in noble gases, means that magnesium is isoelectronic with oxygen ions. This is the meaning. I think that you get something. What is lattice energy? And state factors affecting lattice energy. By definition, is energy required to break down ionic solid and convert ions into gaseous ion by endothermic process. By exothermic process, is energy released when gaseous ion bind to form ionic solid. Yes, you understand? Do you understand? If we have sodium, if we have a sodium, this sodium chloride, this is the ionic solid. If it is ionic solid, yes, there is a breaking down into ions. Yes, sodium plus ions plus, yes, plus chlorine. This is the ionic. When it is when the ion bind together, they form this. This is exothermic process. This is endothermic. When this ionic, when this ionic solid is broken down into ions, gaseous ions is by endothermic. When there is a bind of these ions to form this ionic solid, it is a process of exothermic. This is the definition of lattice. Then factors affecting lattice energy, we have charges on the ions and radius of ions. This is the two factors. Here we have the summary about ionization energy, lattice energy, and electroaffinity and electronegativity. This is the general difference. Here, what is ionization energy? Is energy needed to remove electron from gaseous atom to form positive ions. First, here we have a gaseous atom. It moves from here to form this gaseous, which is ions plus 1 electron. When this is the first ionization energy. If it is the second ionization energy, we have a 2. We have a 2 plus 2 electron. If it is the third, we have a 3. What about lattice energy? Lattice energy is energy needed to break down solid, to break ionic solid into gaseous ion by endothermic, and is energy needed released when to bind gaseous ion to form ionic solid. Yes, ahangaha tuba dufite ionic solid. Hano hakaza kuba broken down, bikaza gutanga this ion, sodium iri gas, yes, plus chloride, yes, iri gas. Ahangaha iyi ngiyi ni ionic solid, iyi ngiyi ni ionic, yes, ionic solid iraba broken down. Ibi ngibi biraba by endothermic. Noneho igihe bizaza kwihuza by exothermic, yes, iyi ngiyi igihe zino ions zihuje bigatanga ionic solid, niyo bita exothermic. By definition ya lattice energy ubwidefinisa mu buryo bwa endothermic na bwa exothermic. Yes, what about electroaffinity? Here is when the isolated atom accepts electron. For instance, if you have atom, then and accept electron. For instance, you have negative. When the electron moves from here to here to form cash anion. For instance, here it is isolated gas. It is isolated gas. Here, atom accept electron to form anion, means that this is electroaffinity. Is ability of isolated atom to accept electron. What about electronegativity? Electronegativity is ability of atom to attract electron toward itself. This is the difference between ionization, lattice, electroaffinity. and electronegativity. Here there is a factors that affect ionization energy is the size of atom, nuclear charge, and screening and shielding. What about the factor affecting lattice energy is the charge of ions, radius or volume of ions. What about the factor affecting metallic strength? We have charged ion, more charges, stronger attraction force between positive and hydroxide electron means that if the charge increases, for instance, across period we have a sodium example. Sodium it is plus, magnesium we have a 2 plus, whereas aluminium it is 3 plus. According to this image, which has more metallic, it is aluminium because it has more charge. As the charge increases, metallic strength increases. This is also size of atom. Small atom, stronger attraction force, and the number of hydroxide electrons. Those are the difference between those key points. Then also the other information have to know the ionization energy have importance. Which importance it has? It helps us to determine metal. Yes, metal. Yes, ionization energy helps us to determine metal and non-metal. How? Yes, metal is when if you have below or near this 800 kilojoule per mole, this is the ionization energy. When it is below means that is less than or equal to this ionization energy. Means that this is a metal. When it is greater than 1800 means that this is a non-metal. This is above 800 is a non-metal. This is the importance of ionization energy. Also, there is another question I have to know. Compare lattice energy for sodium fluoride, sodium chloride, sodium bromide, and sodium iodine. This sodium fluoride is greater than sodium chloride, and this greater than sodium bromide, greater than sodium iodine. Why? As the size, first is you have fluorine. This is a halogen. Also you have bromine. Sorry, this is a chlorine. The fluorine, it is a bromine. The last one is iodine. It is iodine. This is the ions. Also the general, it is a sodium is here. As is first is down group. The size increase means that as the size increase, yes, lattice entropy decrease. Lattice entropy decrease. From here, sodium has fluorine has a greater than chlorine, means that iodine is has lower lattice entropy. Also for here also it is the same. We compare the size. This is the answer. Other question: why magnesium oxide is greater than sodium chloride lattice? For instance, you have magnesium oxide. By comparison, lattice entropy it is greater than sodium chloride. Why? Because the size of magnesium is greater than the size of sodium. And also other things you have to know. Oxide ion means that you have oxide ions is greater than chloride ions. Those are the supporting evidence to explain this question. Yes, right. Yes, why group 18 have no electronegativity? Because group 18 is stable. Yes, it is stable. If you have a 2 electron, it is only 8. They have 8 electron, means that is stable, means that there is no electronegativity, because electronegativity is a powerful atom to attract electron. Here, because it is stable, no attraction. Yes, other question: why further ionization energy is greater than the second and is greater than the first one? Why? Because electron is closer to nucleus, means that it requires high energy to remove electron. The further ionization energy, electron is closer to nucleus, means that to remove electron, another electron, it requires high energy.
Yes.
The question one. Why magnesium oxide is greater than sodium chloride in terms of lattice entropy? Why? Because the magnesium ion is attracted to ions in sodium chloride ion is attracted with one electron. Yes. Oxide ion is smaller than chloride ions. Means that as smaller than chloride ions. Then means the ions are closer together in a lattice and increase the state of attraction. Yes, as the ion is closer together, yes, the lattice increase the state of attraction. Then the question two, yes, why ionic compound is hard and brittle? Explain why. This is the question two. Yes, why? It is hard because it requires mechanical force to separate the electrostatic force. Why is it brittle? It is due to repulsion between like charges. Yes. Yes, you see, if we wanted to why ionic compound, yes, compound are brittle. Ionic compound are brittle. They shatter when the ionic bond are stronger. So they are. Why doesn't it happen? You know, this is the force. Now we have the force. Then force, this is we have example sodium chloride. This force, when they excite on this electron, there is a repulsion between, yes, like charges. There's like charges repelled each other. Yes, there is a repelled each other. Yes, there is a repel of each other, and also the ionic causing to shatter. Then why the latter is the heat layer of ions in shifted, so the ion with the same charges, yes, are lined up together. Whereas there's a repair of repaired or repulsion between like charges. Like charges, it is repaired each other. If you wanted to go to find more information, try to access this link. Discuss the order of lattice entropy for group 1 chloride and sodium halide. Example, we have this sodium fluoride is yes, and sodium chloride, sodium bromine, and sodium iodine. Yes, you see the order of lattice entropy as the size increase. Yes, as the size increase, you know, here we are going to compare the size of halogen. Yes, we have this one. As the size increase, yes, the lattice, yes, decrease. You know, then, yes, as the size increase, means that you have iodine have this, fluorine has like this, have a smaller size, whereas iodine has large size. Then as the size increase, the lattice also decrease. Also here we have lithium, we have sodium, we have potassium, we have rubidium, and also cesium. Here we compare yes, lithium. We focus on the size of lithium, size of sodium, yes, size of potassium, yes, size of rubidium. Also down group, the size, yes, increase. Yeah, the size increase as the size, yes, as the size, yes, as the size, yes, as the size increase, yes, lattice, yes, lattice, yes, lattice decrease, yes, lattice decrease means that here we have the lattice energy is greater than this and this. Means that down group is this lattice of sodium decrease as the size increase, yes. I think that I try to, yes, as the size, yes, means that as size decrease, yes, the lattice decrease as size increase. Homework on lattice entropy. Try to assess this leak to find more questions. Among these, yes, which set of compound is the following pair ionic compound has a higher lattice entropy? Yes, we have this question. Then try to find the answer for this question. If you want yes, try to go in this site and find the answer if possible. Yes. The end. Thank you for your kind attention and God bless you all. Thank you.